Hello, in the last video, Professor Yip-Hoi talked about how to create the tool catalog down here, or how to import the tool catalog into the resource list. And I wanted to talk about what you can do with these tools now that they're down here. So if you double click on any of these tools, you will see that it comes up with a description of the tool, and in a later video Professor Yip-Hoi is going to talk more about what you can do here, but just to give you a sneak peek of what you might want to do, especially when you first import them, you can see that the tool has a name, and you can change that name if you want to describe it differently. You can also see that the tool has a tool number. One thing that is unique about the tools, the way that they're numbered here, is that they are almost completely invalid numbers for going into our machines. So the VF, the big machines that we have 20 tools in the tool changer, and the mini mills have 10 tools in the tool changer. And so you'll see that this is tool number 35. Well, we numbered it as 35 so that it wouldn't block up one of those 10 positions, because you might need some of these tools but not need other of these tools. So one of the first things you should do when you import this tool list in here is you should choose which tools are going to go in which order and come in and change their tool number. You'll notice down here the 1/2" dowel pin we always use as tool number 1 in all of our machines, and so you can see that it has the position of tool number 1. In this class, we will give you tool lists and tool positions where we want them to be, and those will match the Vericut model so that you can check things more reasonably. And so I would suggest that as soon as you load this list in here, you go and you set the tools that you're going to be using. And so, for instance, this is the 1/2" carbide mill. We almost always use that as tool number 2. So I would just go ahead and change that to the correct tool number, and then when I hit OK, this will change that number for the tool. Also in here, you can change all of these values about the tool. So if you had planned to use a 1/2" tool, but then it ended up that you only had a 3/8" tool available, or instead of a 4 flute, it was a 2 flute, any of those kinds of things, you can come in here and you can double click these things and change the parameters, and it will update this window. Remember, you will find that you can also change them here by hitting the More button. So this is one of the tricky things of CATIA, is that this More button hides a tremendous wealth of information. It makes it look like there's very little to a tool when in fact there's a huge amount of information here, and so that's really important to know. When we go in here, you can change all of these values, but it also has the feeds and speeds at the back. And this is a really important tab. So the third tab over is feeds and speeds. The reason that this is important is that by setting the feeds and speeds here, any time that you use this tool in all of your processes where you reference this tool resource this way, if I come in and change the feeds and speeds for that tool, it will update it throughout all of my programs. And so you can cause a lot of harm, or you can make a lot of things better just by adjusting it right down here. Now, sometimes within a machining operation, we will choose a specific set of feeds and speeds for that operation only, and we will unlink that that usage of the tool from this tool definition, but that won't happen all that much. We would rather change it here and have it propagate all the way through. Now, some things to note is that the units are weird here, and it's important to look at this and to think of some of the discussions that we've had in class of calculations. So if you remember, right here we have the finish cutting speed in feet per minute. So this is surface feet per minute, and then we have the finishing spindle speed of turns per minute. So by turns per minute, that is what CATIA uses to refer to RPM. Remember from class, that the spindle speed is 12 times surface speed over pi times the tool diameter. And so If we get our calculator out here, and this is listed at 785, so if we do 785 times 12 divided by pi and divided by the tool diameter, which for this tool is 0.5, we'll see that we get 6,000 RPM. Now, generally, that would be the direction we would go if we got the information from a book on what the surface footage ought to be. A lot of times we will just enter the RPM number just because we happen to know how fast we want to run things, and so you may be given that number as well. Then down here in the next two, you can see that we can either state the finishing feed rate per tooth, or we can state it as finishing feed rate. And so you just select these check buttons. Notice that when I change it for the finishing, it also changes it down here for the roughing number. And so how do we do this calculation? Remember, one of the things that will happen is a book might give us this inches per revolution. If a book gives us inches per revolution, remember that we're going to take inches per revolution here, and then if we multiply inches per revolution times the spindle speed, we will get the machining feed rate. Machining feed rate is often enough a number that we're more familiar with. I would suggest using the finishing feed rate instead of the finishing feed rate per tooth, unless you happen to be given that particular information by the manufacturer. It's easier to not have to keep track of how many teeth each cutter has, because sometimes we change that when we go from one to another. So you can see that this is, well, let's go down here to the roughing feed rate, 2 times 10 to the minus 2. And so if we get our calculator back and we say 6,000 RPM times 0.02, that gives us a machining feed rate, a roughing feed rate of 120 inches per minute. And so that will be something that we'll find later on. There are other things down here. The axial depth of cut for roughing and the radial depth of cut for roughing are only used as suggestions. There are ways to remember what you use with this tool, but they do not set any parameters in CATIA. They are just there for information. Similarly, most of the things on this technology tab are the same. The one exception is the, well, let's see, yeah, the one exception is the number of flutes right here. Matters because that's the number of teeth, which affects this feed rate per tooth calculation right here. You can see that right now we have 3 flutes, and you can see that the finishing feed rate per tooth is 1/3 of the finishing feed rate per revolution, and that's because during one revolution 3 teeth go by. Okay. So that is what we can do with the tools. So I would suggest that as soon as you import them, you go in and immediately go in and set those tool numbers to the positions that you want them to be in your process. One thing that you will be doing with that information later on is you will be creating a setup sheet like this. This helps you know when I get to lab, tool number 1 needs to be which tool, tool number 2 needs to be which tool, and this gives you a list of all the tools, so as soon as you get to lab, you know how to set up the machine and there isn't any question. There's also a picture down here where we're going to talk about where the machine coordinate system is. We'll get to those things later. A few other quick things that you may want to do with the tool catalog. So let's say that I have this 1/2 inch carbide end mill and I want to create a 1/4 inch carbide end mill, and I don't want to do a whole lot of work doing it. One way to do it is to right click, and I go to NC Resources, and from NC Resources I can say Duplicate Resources. When I do that, see another mill happen down here. If I double click on it, it has the same tool number. But what I can do with this is now I could change this to a 1/4 inch carbide end mill. We'll say that those things were the same. I want this to be tool number 3, let's say. And then I'm going to go down here change the body diameter or the cutting diameter to a 1/4 inch, change the body diameter to a 1/4 inch. I would probably change the length if it were changed. And then I would go in and change some of my feeds and speeds because they would be different for a 1/4 inch tool than they would for a 1/2 inch tool. But that's how I create new tools. Well, let's say that I accidentally get tools down here that I don't want. So if I'm going to be working on this part and I don't have a 1/4 inch mill, how do I get rid of it? You can drive yourself batty trying to get rid of things on this page, but the way that you do it is to right click on the item, go to NC Resources and say Delete Unused Resource. And when I delete the unused resource, it will go away. That is the only way to delete something out of this table. Also note, you have to be a little careful because if I select all of those and then go to delete unused resource, it will delete any tool that is not already being used in a process. Okay, those are some of the things that you can do with your tool resources, and in the next videos we'll look at how do we use those in machining the part. Thanks for watching.